Today we are working on special right triangles. So our first kind of special right triangle is a 45, 45, 90 triangle. And 45, 45, 90 refer to the degree measures in the triangle. So as you'll notice here, we have a 45, 45, 90 triangle. And the 45, 45, 90 triangle is half of a square cutting along the diagonal. You'll also notice that this is an isosceles triangle because two of the sides are congruent. And because this is an isosceles right triangle, we know a pattern that happens with y. So if you take 6 squared plus 6 squared equals y squared, like you would for Pythagorean theorem, and 36 plus 36 equals y squared. Then we take 72 equals y squared and take the square root of it. But we're going to take and simplify the radical, and we're going to simplify radicals all day. So we're going to take and factor this, so we have a perfect square. And when we're dealing with special right triangles that are 45, 45, 90, it's always going to be 2 times a number. And in this case, it's 36. And that factors into 6 and 6. So our answer for y would be 6 square root of 2. Now, some of you may have noticed that 6 is the side length, and it's the number in front of the square root of 2. That's what is always going to happen. So you have your side length values, which are your shorter sides, and then your hypotenuse value, which is your side length times 2. So again, our side length, short sides, which are congruent, are both x. And then our hypotenuse, which is our longest side, is x times the square root of 2. Okay, so now we're going to work some examples like this. I do want you to label your 45, 45, 90 triangles like this. So your short sides are x. They're the sides that are making up that right angle. And your hypotenuse, your side across from your right angle, is x square root of 2. So we're going to label our short sides are x's. Our hypotenuse is x square root of 2. So on this one, we know that x equals 7. So this other side is also 7. That means that our hypotenuse, which is x square root of 2, is 7 square root of 2. So that's this side up here is 7 square root of 2. Again, on this next one, we still have a 45, 45, 90 triangle because these two angles are congruent. Again, I'm going to label my sides. My short sides are both x's, and my long side is x times the square root of 2. It's the hypotenuse. So I know that x here is 10 times the square root of 2. So this side up here is 10 square root of 2. That means I plug in 10 square root of 2 for x here for the hypotenuse. So 10 square root of 2 times the square root of 2. Now the square root of 2 times the square root of 2 is the square root of 4. And the square root of 4 is 2. So 10 times 2 is 20. So I could have done this quicker and just known that when I multiply my square root of 2 times square root of 2, I'm just multiplying by 2. So 10 times 2 gets me 20. Next one, I still have a 45, 45, 90 triangle here. So I'm still going to label my short sides are x. My long side is x times the square root of 2. So we have our hypotenuse, we have the longest side, and it equals x times the square root of 2, so we need to solve for x. That means we're going to divide by the square root of 2 on both sides and do like what we did a couple of days ago. So we have x times x equaling 16 over the square root of 2. And we need to multiply by the square root of 2 over the square root of 2, which equals 16 square root of 2 over 2, because the square root of 2 times the square root of 2 is the square root of 4, and the square root of 4 is 2. And this can be reduced because 16 is divisible by 2, and that equals 8 square root of 2. So both of these sides, which are x, are 8 times the square root of 2. So again, make sure you label your sides, x, x, and x square root of 2 for the hypotenuse when you have a 45, 45, 90 triangle, and solve for x, and then substitute it back in. Our other kind of special right triangle is a 30, 60, 90 triangle. Now you will notice that the 30, 60, 90 triangle is made by cutting an equilateral triangle in half. So we have our hypotenuse, which is 2 times as long as our short side. So it's 2 times as long as our short side, which is L. So then we need to find our middle length side. So we have 5 squared plus y squared equaling 10 squared. 5 squared is 25 plus y squared equals 100. Subtract 25 from both sides, and we get y squared equaling 75. And then we're going to take the square root of both sides. But again, we're going to simplify the radical, which means we need a factor. Now, on a 30, 60, 90 triangle, it's always going to be a factor that's 3. So 75 divided by 3 is 25, and that's our perfect square. And remember that factors into 5 and 5 for our perfect square. So that means that y equals 5 times the square root of 3. Now, some of you may have noticed that this 5 is the length of the short side, or it's half of the hypotenuse. It's what's always going to happen, and it's always going to be square root of 3. So on these, I'm going to change the x's to l's so you don't get it confused between the 45, 45, 90 and the 30, 60, 90. So on the 30, 60, 90, your shortest side is L. Your middle length side is L times the square root of 3. And your longest side, your hypotenuse, is 2L. Remember, your hypotenuse is always across from your right angle. So on a 30, 60, 90 triangle, you're going to label your sides. Your short side is L. Your middle length side is L square root of 3. And your hypotenuse is 2L. So on this one, our hypotenuse is the one we have. It's 2L. Short side is between 90 and 60. So that's L. Long side is between 30 and 90. That's L square root of 3. And we have that 2L equals 16. So we need to solve for L by dividing by 2. And that gets us L equaling 8, which means our short side here equals 8. And then we can plug that in for our middle length side, which is going to be 8 times the square root of 3. Our next one, we still have a 30, 60, 90 triangle. Again, we need to label our triangle. We have our middle length side. That's L square root of 3. Short side's on the left, so that's L. Long side, our hypotenuse is 2L. we need to solve for L because we have L square root of 3 equaling 12. We're going to divide by the square root of 3. That gets us L equaling 12 over the square root of 3. We're going to do like we did 2 days ago and multiply by that square root of 3 over square root of 3. And that gets us 12 square root of 3 over 3. Because remember that the square root of 3 times the square root of 3 is the square root of 9, and the square root of 9 is 3. And then 12 divided by 3 is 4. So that means that L equals 4 times the square root of 3. So that's our short side, is 4 square root of 3. And then we need to plug it in for our hypotenuse. So we got 2 times L. So we're going to do 2 times 4 square root of 3. And when we multiply this, we only multiply the number in front of the radical, the number in front of the square root sign. So that gets us 2 times 4, which is 8, times the square root of 3 for our hypotenuse. And then our last one on the notes, again, label your triangle. It's still a 30, 60, 90 triangle. So we have L for our short side, L square root of 3 for our middle length side, and 2L for our short side. We've got L, so all we have to do is plug it in. So this is going to be 9 times the square root of 3, and then 2 times 9 is 18. Now remember that when you type in a square root in the computer, that you need to write 9 and then multiply, or a parentheses, and then square root SQRT, open parentheses, 3, close your parentheses.